Alright, welcome to lesson 5. We're going to do two more things with this elasticity concept. We're going to talk about how elasticity works along a demand curve, because there will be a lot of times when we're analyzing demand curves and looking at producer and consumer behavior where we want to use the elasticity concept, and so we'll see how that lines up. And then second, there's a few other types of elasticity. So far we've talked only about price elasticity of demand, and there's other ways that we can apply this concept of responsiveness to price changes that are also interesting. So we'll do both of those things in this lesson. So first, starting off, elasticity along a demand curve is the first slide you see in front of you. What we're going to do here is kind of a bunch of math to illustrate and to try to kind of ingrain in your head of how elasticity works along a straight line demand curve, so that every time this comes up that you kind of get it, internally, instead of trying to just kind of memorize here's how it works. You could do that, but I think it helps a lot to really get the math behind it, and I also think that makes it just kind of more fun and kind of cool, and I'm just going to hope to get you as excited about it as I am, which is probably difficult. But here we go. So we're going to do, I'm going to show you kind of with math how elasticity works along a given straight line demand curve. You can see down here on this demand curve that it's got a constant slope. It's got a slope of -1 actually. But the one thing to get across here is that elasticity is not the same as slope. And even though the slope is constant on a straight line, elasticity is not constant along a straight line because we're dealing with percentage changes, not just numerical absolute changes. So you're going to see along this straight line demand curve, the elasticity varies. And the cool thing is it varies in the same way, in consistent ways, along any straight line demand curve. There's some things that are always true about elasticity along a straight line demand curve. So the way I'm going to show this is to find the elasticity using the midpoint method of three different pieces of this demand curve. First, of line segment AB up here at the top, second of line segment DE down here at the bottom, and third of this point C. This is the first time we've seen this, but we can find elasticity of just a single given point. We'll show you how to do that. Okay, so first, to use the midpoint method to find the elasticity of demand of segment AB, we're going to put the quantity change on top. Remember, our midpoint formula is the change in quantity over the midpoint of the quantities, 1/2 Q1 plus Q2, over the change in price over the midpoint of the prices. That's the formula I'll be using for each of these examples. So for AB, we've got a change in quantity from 0 to 2, so that's 2. The midpoint of those quantities is 1. Then in the denominator, we have the change of price from A to B of 2. Again, we're not going to have to worry about signs in this because we're always using the absolute values with price elasticity of demand. And then the midpoint of the prices, our prices are 8 and 10, so the midpoint is 9. Okay, let's simplify this to 18 over 2, which is equal to 9. So the elasticity of segment AB is 9. That's highly elastic. Remember, anything over 1 is considered elastic. Okay, next we'll do segment DE. Change color here. The change in quantities, we've got quantities from 8 to 10 for DE, so the change is 2. And the midpoint of those quantities is 9. Prices from D to E are from 0 to 2, so the change again is 2. And the midpoint is 1. Simplify that, we get 2 over 18, reciprocal of the other one, which gives us an elasticity of 0.11. So that's highly inelastic. So right there we've already shown that along the straight line demand curve, even two segments that have the same slope, if you found the slopes of AB and DE, they would be equal. The elasticity is quite a bit different. Okay, let's find this point C, and then we'll talk about the relationships that always hold here. So to find the elasticity of a point using the midpoint method, all you have to do is take that point as the midpoint of any line segment. And we could even create our own since we know the slope of this line, but let's just use the points that we're given. You could use C as the midpoint of segment BD, as I say here, or C is also the midpoint of the entire line, or segment AE, I guess you can call it. So let's just go with the first one and find the elasticity of segment BD. Okay, the change in quantity from B to D, from 2 to 8, that's a change of 6. Over the midpoint from 2 to 8 is 5. Change in prices from B to D, from 8 to 2, that's also 6. And the midpoint of the prices from 8 to 2 is again 5. That simplifies to 1. And remember from our definitions, 1 is defined as unit elastic demand. Okay, so to sum up, we've shown that this segment up here is elastic. This point here, C, is unit elastic. And this segment down here, DE, is inelastic. Those relationships are always going to hold, and here's exactly what it's going to be. The midpoint of the demand curve. Midpoint, we're assuming the demand curve stretches all the way from one axis to another, and it needs to when we do these problems. So the midpoint, which we can see here is just 5 in the midst of from 0 to 10, is always unit elastic. The midpoint of the demand curve. Excuse me. We'll say midpoint of demand. Above that midpoint, every point and segment above it is elastic. The elasticity of different points, they'll all vary, and it'll get more elastic as you travel up the demand curve towards the y-axis to the point at the top here where it's what's called perfectly elastic. Where the measurement of elasticity, you have a 0 in the well, the measurement of elasticity is undefined, is the important thing there. Undefined elasticity. But it's called perfectly elastic. Okay, then everything below the unit elastic point, everything below the midpoint of the demand curve is inelastic. And again, it'll vary and get more and more inelastic all the way down to the bottom. This point on the x-axis is perfectly inelastic. We'll have an elasticity of 0. Okay, so those relationships will always hold along any demand curve. We're going to make a lot of use of that as we analyze producer behavior later in the semester. So basically what we're showing is that we've got two different segments of a demand curve where that relationship is always there. We can also say one more application of this. If the producer, remember we talked about the relationship between total revenue and raising your price, and whether the demand at that point is elastic or inelastic. Say that currently the producer's in the elastic portion of the demand curve. They're at point B, price of 8, quantity of 2. We know that if they raise the price, then the total revenue is going to, think about it for a second, see if you remember. Total revenue is going to fall. In the inelastic portions of in the elastic portions of the demand curve, it means that consumers start buying quite a bit less when the price is raised, so the total revenue falls. Whereas if you're in the inelastic portion, if the producer, say you're at point D, if the producer raises the price, then increase his or her total revenue. Let's see if I can keep that from messing it up. Let's try again. Increase the price leads to increase the total revenue. So we learned that yesterday. I'm just kind of applying that now to here. So if a producer knows his or her demand curve, knowing whether they're in any elastic part or an inelastic part, then that can be helpful for knowing the effect of price changes. Okay, new topic more or less, still elasticity, but now we're going to talk about other types of elasticity, not just elasticity of demand for a good, but there's other ways to apply a kind of similar concept. So the first is cross-price elasticity. Here we're going to be talking about two different goods. I called them in this slide goods A and B. Let's say good A is hot dogs and good B is hot dog buns. An increase in the price of hot dog buns we know will decrease the demand for hot dogs because they're complements. We've seen that back in basic supply and demand. And if we could put numbers on this, let's say that the increase in price of hot dog buns is 10%, and that decreases the quantity of hot dogs demanded by 5%. We can find what's called the cross-price elasticity of demand using this formula. Again, the quantity goes on top, as it always does, and now the sign is important when you're working with cross-price elasticity of demand and income elasticity, which we'll do next. You can't just take the absolute value anymore because the sign is now significant. So we've got a decrease in 5% quantity demanded of hot dogs over an increase of 10% in price. We'd say the cross-price elasticity of demand for hot dogs and hot dog buns is negative 0.05. Let's do another example with two different goods. Let's keep A as hot dogs, actually, but let's change B to hamburgers. Say that an increase in the price of hamburgers of 10% leads to, we find from the data, say an increase in quantity of hot dogs demanded of 5%. Why would that happen? Well, maybe the increase in price of hamburgers has led people to buy more hot dogs instead of hamburgers. So again, we take the quantity demanded of A. Now it's positive 5%. We've increased the quantity demanded of hot dogs over an increase in the price of hamburgers of 10%. So our cross-price elasticity of demand between hot dogs and hamburgers is positive 0.5. This illustrates something about the sign of the value of the cross-price elasticity of demand and whether the two goods involved are substitutes or complements. If the sign is negative, as it is for hot dogs and buns, then they are complements. If the sign is positive, as they are for hot dogs and hamburgers, then they are substitutes. And the relative value, the higher the cross-price elasticity, 0.5 versus say 1 or 1.5 or 2, the higher the cross-price elasticity, the stronger the complement or substitute relationship. Higher cross-price elasticity means stronger relationship, whether that's a complement relationship or substitute relationship. If there's a very small effect on the quantity demand of the other good, that's a weak substitute or complement relationship. Okay, another kind of elasticity we can use is called income elasticity of demand. This has to do with how a person's or how the market's purchasing of a good responds to changes in their incomes. So again, let's go to hot dogs. Say that if people's incomes increase by 10%, that the quantity demanded of hot dogs increases by 5%. People have more money, they buy more hot dogs. That makes sense. The income elasticity of demand for hot dogs based on this data is change in quantity demanded 5% over the change in income 10%. So 0.5 would be the income elasticity of hot dogs. Let's take a different good. Let's take Spam. Anybody a fan of Spam? Most people do not like Spam. And the reason Spam exists, at least in the United States, is as a kind of cheap substitute meat when you can't afford better meat, to put it mildly, I think. If an increase in incomes, say that people's incomes are increasing, we could predict that Spam demand would decrease because people would now switch from Spam to better meat. So say that an increase in income of 10% leads to a 5% decrease in the quantity demanded of Spam. Now again, the sign is important. For the income elasticity, we're going to do negative 5% over positive 10%. We get a negative 0.05 measurement of income elasticity for Spam. That tells us that Spam, the negative sign, tells us that Spam is an inferior good, whereas the positive sign for hot dogs tells us that hot dogs are a normal good. Remember those definitions from basic supply and demand. A normal good is just one where when your income goes up you buy more of it. An inferior good is one where if your income goes up you buy less of it. So the sign there gives us basically the distinction between a normal good and an inferior good. Also, the higher the sign of a normal good, or the higher the measurement of income elasticity, then the more the good is a luxury. Higher income elasticity equals more of a luxury. If your income goes up but you don't buy that much more of something, that means it was probably more of a necessity. You were probably buying just what you needed of it, and it was necessary in some sense. Whereas if your income goes up and then that really leads you to buy something you definitely wouldn't have bought before, it's probably more of a luxury for you. Okay, lastly, and we can do this real quick, the price elasticity of supply works exactly the same as it does for demand. So all we need to do here is make the point that you can measure the price elasticity of supply the same way as you can measure the price elasticity of demand, by the change in the quantity over the percent change in the quantity over the percent change in the price. We'll talk about the kind of relative elasticities of supply and demand and how that's significant in the next chapter. Just conceptually, think of price elasticity of supply as, okay, if the price goes up, how many more producers does that induce to come in and produce the good? We talked about corn back with supply and demand. If the price of corn goes up, how much does the price have to go up to bring more farmers into the market? If the price elasticity of supply is very elastic, that means if the price goes up a little bit, then a lot more people will switch over to corn. Whereas if it's very inelastic supply, that means even if the price goes up quite a bit, it won't bring many more farmers into the market to produce corn. Okay, we'll stop there. See you in class.